Well, I guess it's recording. Something went wrong when I was trying to start the recording, and I wasn't sure if it was going to start or not. But yeah, any rate, uh, getting close to another sunset. I noticed that I noticed that the sunset was getting close, and that the live stream is up and working right now. So I thought, oh, what the heck? I'll try to grab another one. This will be my second uh, sunset screen capture from the International Space Station's live stream today. At least by my time zone. I'm in United States Pacific time. It's 8:27 here right now, um, and on December 3rd. So let's see. In Eastern time, well, it'll be tomorrow in uh, less than half an hour. Um, but yeah, thought I would go ahead and just film another sunset. I don't have anything planned particularly to say. Um, I I don't expect anything other than static for audio if I don't say something. So I suppose I should probably talk, but I don't know about what. Um, Pretty much said everything in the earlier videos. Of course, not everybody watching this one will have seen the other ones. So let's see. I could briefly recap a few things. Um, let's see. Oh, if you look near the top, you'll see the darkness starting to set in there. Notice the bottom of the area of the globe that you can see is a lot brighter than the top bottom right area of the screen and the top left area of the screen. There's quite a bit of difference in brightness there, and again, most of what appears to be the Earth rotating in the background, as I explained in the earlier videos, um, is actually due to the space station orbiting the planet much faster than the planet actually rotates. That's quite a bit of land zipping by underneath. It might not look all that terribly fast. It depends on what scale you imagine that to be. But well, I mean, imagine looking up into a sky and seeing a jet plane moving that fast in comparison to, say, buildings and stuff like that. Um, it would be quite a bit faster. This would be quite a bit faster than that because there's quite a bit more distance involved. Uh, as a matter of fact, we're talking about 200, literally 254 miles away. So if you can imagine a jet 254 miles up in the sky, well, that's where the International Space Station is. If you can find it with a telescope, actually, I think it should be visible with the naked eye under the right conditions. But you've got to catch it at times like this, like when there's a sunset going on, um, a sunrise or a sunset. Either way, when you're in the twilight hours, there's a short time during which the space station is well lit. That and during which time the ground that you're on is not well lit, and during that time you should be able to get a good look at the space station um, off in the distance toward where the sun went down. Um, Headed well, yeah, headed into the darker area. So, at any rate, I don't know if I'm wording that very well, but yeah, just like I said, thought I would try to grab this screen capture while I had the opportunity, and the colors are sort of interesting to note. To just see how it all works. I wish I could zoom out and show you more of the picture. I don't have any way to do that because obviously I'm not controlling the camera. I'm just capturing an image on the screen from the International Space Station's live stream camera. If you check the site, and I will make sure that when I crop this video, that I leave the um, address showing. Hopefully, the resolution will be high enough that you'll be able to read it. Here, I can read it off right now just in case. www.ustream.tv/channel/live ISS I'll spell that out letter by letter. www.ustream.tv/CHANNEL/LIVE ISS STREAM. And if you go to that address, you'll be able to check out the live stream yourself. It's down once in a while. Sometimes you'll hear the audio a little crackling, or maybe somebody talking, but not have a picture. It might just be like a blue screen. And I've found that at times when it's like that, if I refresh my browser, it'll kick back in. So at least some of the time, I think it's on the browser's end. But I have also noticed people in the live chat area. There is a live chat area, by the way, and I have noticed people in there once in a while telling someone that it's not on their end. So I'm not sure the whole story behind that, but the thing is, you can check it out for yourself if you want and see a lot more than you'll see on my short videos of it. Of course, you won't have my commentary to go along with it, and that may be a good thing or a bad thing depending on your point of view. Notice that the sunlight on the Earth, on what you can still see of the Earth, is down to basically the last little sliver in the lower right-hand corner of the screen on the horizon. That is actually the horizon, by the way, and I know we're used to thinking of the horizon as something you see below you, but if you can picture that arc of a circle and imagine about where the center of the circle would be, and just imagine that this is like a bulging out from your screen into a big hemisphere. Actually, not even a hemisphere, a sort of a bulged disc. Um, if you can imagine standing at the top center of that bulged disc and looking out to where that edge is the farthest out thing you can see, that's what that is. That's the hemisphere, or that's the horizon. And from any position on Earth, you're always going to have a horizon out in the distance, all 360 degrees, no matter what your altitude is. If you get high enough up, that horizon goes farther out. Um, you might be able to see 5 miles out, or 30 miles out, or 130 miles out, or 300 miles out, or 1,000 or 2,000 miles out, like in this case, or at the extremes, maybe 6,000 miles out. Um, Eventually, it gets to the point where it's wrapped so far around that it wraps back in on itself, and you can't see any farther than that, no matter how far away you get. But yeah, I'm just explaining the geometry of it. Um, for those people who don't either don't understand the geometry of it, maybe don't understand it fully, haven't had it explained to them, whatever the case might be. I expect most people don't need this explanation, but it's there for those that find it useful or amusing or whatever the case might be. Any rate, looks like the sunset is about done. That's all there's going to be of it. No really pretty colors like you might see when you're looking at it from on the ground. That's just a difference in perspective, and also again the camera angle. Now they do change the camera angle from time to time. Once in a while they'll change it around, and I managed to get some nice pictures on Twitter recently of sunset where the sun actually showed up for a short time in the scene, and there was a lot of glare and bright colors, and it was rather interesting. Um, not not a real clear picture, but it was pretty. And oh, there goes that. That's what it looks like when the picture goes out. So I'll leave it at that, and I'm going to go ahead and stop the video. But do check it out for yourself sometime, and maybe you'll catch it when the camera's at a better angle. Also, if you go to what is it, time and day timeanddate.com slash world clock slash sunearth.html, you can see where the moon and the sun are in relation to the ground. Now, that's very far away. The moon is 250,000 miles or so away. The sun is like 92 million miles away. But what it shows, the little image it shows, is basically representing an approximate area on the ground, where if you were standing, if you looked straight up, the sun or the moon would be directly above you from that position. And another thing that might be useful if you're looking to check out the space station video, looking for a sunset like I just did here, or a sunrise, is iss.astroviewer.net. And as you can see in this image here, this little plus sign is just approaching North America. It's coming up on the edge of Alaska there. And this blue area, this blue path, is roughly where the station itself is in darkness. So from about there to about here, and notice the gap over here between the two ends of the red line. That actually is one full orbital path, 92 minutes. The reason why there's a gap there that it won't have covered by the time it's made a complete orbit of the planet is because the planet itself is also moving during that time. So that's how far the planet rotates toward the east as the International Space Station makes one complete orbit toward the east. So that much of it has to be made up afterward to be able to get back over the piece of land it started over at the beginning of that orbit. So that's why the movement of the planet underneath you on the space station feed is so obvious. Now, I say obvious. Is it back? Yeah, it's not obvious when it's that dark, obviously, and it's not obvious in the sense that flat earthers make it out to be, a spinning ball with things flying off of it everywhere, and stuff not being attracted by gravity to the ball itself, but attracted by a universal down direction, which would make things fall off of the ball. And I don't understand why so many of them think that down has to be one direction in a straight line that's the same everywhere, and yet north can be to the left on your map, or to the right on your map, or downward on your map, or upward on your map. And they think that if you lay that map down, that's just a scale model of the planet with nothing changed. So literally, that two people can be walking directly toward each other and both be walking north. Yeah, how they can justify thinking north works that way and down can't work that way, I don't know. But if you have two people on opposite sides of the planet, literally opposite sides of the globe, both falling downward, they are falling toward each other. Just like on the most accepted flat Earth maps, if two people are walking north from opposite sides of that flat planet, they would be walking toward each other. And if they're walking south from opposite sides of that planet, they'd be walking away from each other, just like two things going directly upward on the globe on opposite sides of the planet from each other um, would be moving away from each other, as well as away from the center of the roughly spherical planet. At any rate, enough of my rambling. Thanks for watching the video.